Hi, I'm Chris Wooldridge, Sales Engineer for Holden Associates, and today we're going to talk about the Greenheck Vektor lab fans, specifically the variable geometry discharge nozzle. We're going to start off with the H series of fans. These are your standard high plume exhaust fans up to 24,000 CFM. Come standard with a roof curb, bypass air plenum, damper and weather hood, inline centrifugal wheel, and exhaust stack. It's a great self-contained economical alternative to a field-built stack, and it's AMCA certified. You'll also see the Vektor HS, the H fan with the new variable geometry nozzle, which we'll discuss in more detail in a minute. Now we'll talk about the Vektor M series of fans. The Vektor M fans use a mixed flow fan wheel for efficient air movement. You'll see the MH, the MD, and the MS fans on your screen. The Vektor MD allows for dilution up to 300% when the application dictates. The Vektor H is similar to the Vektor MH is similar to the Vektor H in that it is just a high plume exhaust with no dilution. The benefits of the M series of fans is the bifurcated housing, which completely isolates the drive components from the airstream during maintenance. The M series can also be used on an ERS plenum, Greenheck's energy recovery plenum, utilizing a coil design that can completely isolate the exhaust airstream from the supply airstream. You'll also see the Vektor MS, which again has that variable geometry discharge nozzle, which we'll soon get to. Now we'll talk about the Vektor C series of fans. The C series utilizes a centrifugal wheel, which can generate higher statics. This is great for heavy filtration applications and can handle statics up to 14 inches. The C series has the same options of the CH, a CD, and a CS. The CD in this case, centrifugal wheel with dilution, can go up to 120,000 CFM. Now we're going to talk into more detail about the variable geometry nozzle. As you can see on the screen, the blades modulate, open and closed, and will do this based on the demand of the space. In applications where less exhaust is needed, the fan motor will slow down, the blades will close, decreasing the cross-sectional area, allowing the system to maintain a 3,000 feet per minute discharge. Shown here is the Vektor MS system. Now this image will show in detail the different components of the variable geometry nozzle and everything that is occurring. Everything from the modulating actuators, moving the variable geometry blades, to the Sure Air non-invasive piezo ring that's connected to a pressure transducer as an airflow measurement, which can then signal to the Vektor controller what is going on in terms of airflow. There are two options that Greenheck can do. We can provide a VFD that's connected to the controller, or if the customer prefers, we can connect it to a VFD by others. Now we'll have a Vektor HS control sequence. This image shows a multiple hood situation where demand may vary based on how many hoods are active and what's actually going on in the space. Point 1 would be a static pressure sensor connected to a BMS. The static pressure sensor will tell us what's actually going on in the exhaust ductwork and how much demand is needed. The BMS then will relay to the VFD and the variable geometry nozzle controller about what's going on, what needs to be done. This controller and VFD will then control the fan motor, telling it to speed up or slow down based on the demand in the space. From this, the airflow ring will tell the controller to signal to the blades and the actuators what needs to take place. So as the piezo ring is telling the controller where we are in terms of airflow, a corresponding nozzle position is occurring. It'll open and close based on the demand in the space. Again, the benefits of this system is saving fan energy without having to use a bypass air damper for variable volume application. Thanks for taking the time to watch this video. and contact your Holden rep for more details and information on the Vektor lab fans and the variable geometry nozzle.